Okay, we're going to go through this virtual lab, the Enzymatic, together by clicking Start a New Game. You are going to have to type something for your name, and we're going to click Continue to a New Game. I do not have a touchscreen, so I'm going to click No. Tap or click here, and that's going to give you some background information. Enzymes are extremely important in biology. Basically, every life process and living things is going to rely on enzymes. So we are going to look at this little virtual experiment to kind of understand them more. Tap or click here. We are going to click on this purple button that says Experiments. We're going to run an experiment about them. It says several factors affect how well an enzyme is able to perform its job. For example, enzymes are affected by temperature, pH, and the concentration of substrates. Remember that thing that fits with the enzyme, what the enzyme is acting on. All of these factors affect the rate at which an enzyme catalyzes a chemical reaction. You will determine how temperature, pH, and substrate concentration affect enzyme function by performing some virtual experiments. So we are going to look at how a specific enzyme is affected by temperature first. It asks you to slowly drag the slider below to see how the reaction rate of the enzyme is affected by changes in temperature and make careful observations. So I have this enzyme in a very low temperature right now, and as I increase the temperature, you can see everything starts to move faster. If you notice the graph on the right, you'll be able to evaluate the rate of the reaction with that line. And right now I'm at this point in the middle where this is at a peak. It's going as fast as it possibly can. If I increase the temperature more, make it hotter, it actually is making the rate of reaction go down. And you can see a little excerpt here that says starting to denature. If you go too high on the temperature, it actually completely messes up your enzyme. It's called denatured, and you notice that there's no rate of reaction, it's zero. And even though the substrates are moving super fast, my enzyme doesn't work anymore. So I'm going to start over and see if when I go to the lowest, if it denatures it, oh, no, it just is so cold that nothing's happening. If I go really high and bring it back down to low, it's still denatured. It doesn't matter. I ruined it. So if you look at this concept, it says the temperature at which the enzyme works best is called its optimal temperature. Basically, that right here on the graph is where it's working the fastest, is at the highest rate of reaction. So this first question asks you, based on your observations, which of the following statements would be true? Did the substrate molecules move faster at higher temperatures? Yes, they did, right? Got hotter, the molecules move faster. Is it true that faster moving substrates collide with the enzyme more, causing the reaction rate to increase until you get to that optimal temperature? Yes, that's also true. Is it true that hotter temperatures always result in faster reaction rates? No, it is not, because even though the substrates are moving faster, my enzyme was denatured and it doesn't work at all. So we're going to click C, and it says, oh, you're so smart, you are correct. Looking at this graph, what would be the optimal temperature for this particular enzyme? And if you go to kind of this peak of the reaction rate, you can see right around 40 degrees Celsius, I have the fastest rate of the reaction. Why does the reaction rate slow down drastically when the temperature is too high? Does the enzyme lose its color and attractiveness? No, that's silly. Do the substrates move too fast? No, moving fast as a substrate is good. It's going to collide with the enzyme more. Is the enzyme losing its shape, denatured, and can no longer effectively catalyze the reaction? That is the correct answer. We're going to pick C, and we know that denatured enzyme is not going to work. Based on your observations of the enzyme shown, which of the following is true? The denaturation of this enzyme by heat is reversible. That's not true. When I went back to a lower temperature, it did not fix the enzyme shape. So the denaturation of this enzyme by heat is irreversible. So once you denature it, you're not going to be able to fix it. So now we're going to check out another factor that would affect enzymes' ability to do their job. The pH scale is a way to measure how acidic or basic a solution is. And if you remember, we talked about low numbers being acidic, high numbers being basic, and water would be right in the middle, around 7, a neutral pH. And enzymes are affected by pH. Let's look at that now. So this enzyme right now is working at its optimal pH, is at the peak of this graph. And if I start to make this a more acidic environment and go down lower, you can see my enzyme starting to denature until I get to the point where it is completely denatured. It's not working at all. And if I bring it back up, it looks like it's okay, right? I fixed my enzyme. And if I go the opposite way, I go too high of a pH, too basic, it's also starting to denature until it's all the way denatured, and now it doesn't work again. So is it true that substrates move faster at higher pH levels? Statement 1. No, the pH level didn't affect how fast the substrates are moving. It did affect how well the enzyme was working. It says there's an optimal pH level at which the enzyme works best. Above or below that, it's going to become less effective. That is true. Is it true that the enzyme denatures or loses its shape at pH levels that are too high or too low? Yes, that is also true. So statement 2 and 3 are correct. What's the optimal pH in this graph? Once again, we're going to look right at where the reaction rate is the fastest. And for this particular enzyme, that pH is 8. That's going to be different for every enzyme. Based on your observations of the enzyme shown, which of the following is true? The denaturation of the enzyme is necessary for it to work. No, that actually makes it not work. Denaturation of this enzyme by pH is irreversible. Well, actually, unlike temperature, it was reversible. When I went back to that ideal pH, the enzyme was able to work again. So we're going to pick D, where the enzyme was able to be fixed when I made the pH optimal again. Pepsin is an enzyme found in your stomach. That is very acidic. So which of the following would probably be the optimal pH for pepsin, which again is in an acidic environment? Acidic is low pH, so something like 2 would probably be optimal for pepsin. Lastly, we're going to take a look at substrate concentration, which is how much substrate is in a solution. So more substrate, high concentration, versus low substrate, less concentration. So my hypothesis is going to be that a higher substrate concentration, will increase the rate of the reaction. Let's see if that's true. So I'm going to add more substrate to this solution. And if you notice, the higher the concentration, my graph is increasing. It is going faster. The rate's increasing higher and higher. But at some point, it's not going down. It's just kind of plateauing. So now I no longer am increasing the rate of the reaction, but it's not denatured. So there is more enzyme activity at higher substrate concentrations because there's more collisions until I reach this maximum rate. That's true. Once the maximum rate is reached, the reaction levels off. That's also true. The reaction rate will always increase if the substrate concentration is increased. Ooh, not true at all. Because once I get to a certain point, it actually plateaus and it no longer increases the rate of the reaction. We're going to say 1 and 2, and we are correct. So how is enzyme activity at varying substrate concentrations different than what we did with temperature and pH? The graph for substrate concentration shows the rate leveling off instead of declining. Increasing substrate concentration is apparent that the enzyme denatures. Oh, not true. We did not denature our enzyme this time. Changes in substrate concentration do not cause the enzyme to denature, but changes in temperature and pH do cause the enzyme to denature. That is true. So we're going to say 1 and 3. It's going to say, oh my God, you're so right. And now we're going to say, was my hypothesis? Yes, it was pretty much supported. I didn't say that it's going to level off. So we're at the last part here where we're going to combine everything we know together. First, I need to choose the correct enzyme for this substrate. We needed to fit in that active site. That would be this one. Then I'm going to set the optimal temperature, which, as you can see in this graph, is somewhere around 30 degrees. Then I'm going to set the optimal pH, which, as you can see in this graph, is somewhere around 7. Then I'm going to set the optimal substrate concentration. I want it to be fast, like the highest rate, but I don't want to do too much or it says it's going to clog the machine. So somewhere around maybe 7 or 8. Let's see if we do 8% what it says. It says, yeah, you're right. Great. Now my enzymatic works and I know enzymes.